I was interested to find out if tube amplifiers warrant all the fuss that's made about them. I'm a bit sceptical by nature, so I tend to consider this kind of thing as mostly hyperbole. But I thought there might be something to it, and I wanted to judge for myself, if for no other reason than I could dismiss the whole thing as complete nonsense. I didn't have access to a reasonable example of such an amplifier, and didn't want to spend a huge sum of money buying one, so I found some parts and built one of my own. The results turned out to be quite surprising to me, and I thought I'd share my experience. Building this particular tube amplifier wasn't actually as difficult as I'd imagined. The technology was a little bit alien, but nonetheless very straightforward. And there were only a few simple steps involved in this build, from sourcing the components, not as difficult as I thought, planning the mechanical layout, which was very straightforward, preparing the housing, which was mostly filing and drilling, making some ancillary bits, which took a little bit more time than I'd imagined, and screwing and soldering the whole thing together, which was good fun. I'm going to go into the build in a bit more detail in a few minutes, but I just want to do a comparative listening test to demonstrate that it is a worthy project to undertake. For this test, I'm going to present 3 versions of the same snippet of music. The first is the original track cut directly into the video. The second is through the tube amplifier with a speaker and microphone. And the third is the same setup but through a transistor amplifier. I chose this particular transistor amplifier as it's a Class A topology, and that's the closest I could get to the tube amplifier's single-ended design. But anyway, here goes, and it's all in mono. I can't in reality tell much difference between the 3 tracks when they're played like this, but listening to the tube amplifier in stereo with a good program source is a different experience altogether. I'm just amazed by the way it sounds. There's an unexpected clarity to it, and the stereo image brings a degree of reality that I haven't experienced before. I can't really show this on a YouTube video, and I don't know if my experience is typical or I've just been lucky. Of course, my experience could all be confirmation bias or some such thing, and a dispassionate listener might regard what I've said as madness. But then, audio is subjective, and a lot of what is considered knowledge might just be in people's heads, including my own. At the start of the project, I didn't particularly have any design in mind. I just essentially searched eBay to see what was available in terms of old output transformers and tubes. During that search, I found a pair of single-ended transformers and 5 new old stock PCL82s. They are the European equivalent of 16 A8s, and as the whole lot came to a few pence under £25, that was that part of the deliberation settled. And whilst I was doing some online research for the PCL82s, I came across an intriguing little design. It got a good write-up on several message boards, and it had a few interesting features that I wanted to investigate. So that kind of settled the remainder of the debate as to what I was going to build. So let's have a look at the circuit diagram for the full project. It's single-ended, which you've probably gathered already, and of course it's stereo, and one surprise might be that it doesn't have a power transformer. In particular, I wanted to avoid those types of transformers for this project because they're big, they're bulky, they're difficult to get hold of, they're expensive, and they're a bit inflexible, to be honest. A better solution seemed to me to be to start with an intermediate fixed voltage supply, then use a combination of buck, boost and linear regulators and converters to generate the required rails. An old netbook power brick providing 2 amps at 20 volts fitted the bill perfectly for the intermediate supply for the project. An LM317 linear regulator works nicely for the 16 volt heater supply required by the PCL82s, and it allows for me to incorporate a slow start circuit, and that's described in the datasheet for the LM317. I've included that to overcome the potential for damage by turn-on hotspots for when the tubes are first powered up. A cheap and readily available high voltage boost converter module from eBay serves as the HT supply, and all it needs is a little bit of extra filtering to smooth out some ripple. I included a regular bridge rectifier and smoothing capacitor, and that appears on the circuit diagram in case I wanted to use a normal low voltage transformer. However, because I'm using an external power brick, they weren't required and I didn't include them in the project in the end. Let's take a look at the circuit diagram in a little bit more detail. The incoming signal goes through the volume potentiometer and a decoupled capacitor C2 to the grid of the triode section. The amplified version of the signal is developed across R3 and coupled to the control grid of the pentode via C1. The output of the pentode drives the speaker via the output transformers, which is shunted by a Zerbal network R7 and C3, which are there to aid stability. And there are a couple of grid resistors R2 and R1, which are there to soak up any grid current. The biasing network is a little unusual, and it consists of R5 and R6. For the pentode, they act in series as a single resistor, and for the triode, they act as a potential divider and generate a bias voltage that is about 1/48 of the pentode bias voltage. Amplifier control is normally implemented as some sort of feedback mechanism. For hi-fi amplifiers, it's almost always a network around the whole amplifier, but not in this case. Instead, the design relies on a number of little local feedback mechanisms. There are three main feedback mechanisms employed. The first is R4, which provides some negative feedback around the pentode. The second is the unbypassed R5 and R6 series combination, which provide a degree of negative current feedback for the pentode. And finally, R5 and R6 as a potential divider network, providing positive feedback to the triode. I'm not going to go any deeper into this here. It's a bit beyond the intended scope of the video. The amplifier is going to be housed in a combination of two boxes. There's a steel box, it's an old network hub. The insides have been removed and the front panel's been taken off. And that's going to form the chassis. On top of that will be a plastic box that is going to house the transformers. The transformers are going to go at the rear. Obviously there's two of them. And I'm going to retain the lid of the plastic box. That's going to give me an extra couple of millimeters height, otherwise they just wouldn't fit in. They're going to sit in the lid as far apart as possible. In front of them I'm going to have the tubes. And then coming out of the front panel in the center is going to be the volume control, and the body of the plastic box is going to round it all off very nicely. I'm marking the feet of the transformers, and I'm also marking a hole for the wires to go through into the main chassis. Those marks are then going to act as a drilling guide for both the lid and the chassis, and I've added a paper template to mark out the holes for the valve bases. There's a pair of large holes for the tube bases, and each one of those has a pair of holes for the associated screws. Below them, in the centre, is a medium-sized hole which accommodates the wires going between the two boxes. Then a large rectangle of 4 holes which are there to hold the two boxes together. And finally are 2 pairs of holes on the diagonal which hold the transformers down. And if you look at the front of the chassis box, there's also a hole in the centre to take the volume potentiometer. I ended up turning one of the transformers around so I could fit some tag strips in. Of course, that needed more holes. The grommet goes into the steel chassis to protect the wires. And the plastic lid has a larger hole to accommodate the outer diameter of that grommet. The speaker terminals will go through one of the holes at the rear of the chassis. It's not quite big enough, I'll end up enlarging that. And the RCA jacks will go in the other similar sized hole. Here's one I prepared earlier. Tighten out the transformers, got the screws together, lid of the box and the grommet are already there, and the transformers. And off we go. Next come the tag strips. It's a double-decker arrangement. They're on long posts with a small separator between them. And they go between the transformers. I want to temporarily mount the main tag strip in the chassis so that I can plan the component placings. It's held off the chassis with spacers and it uses the same bolts that hold the main transformer box on. I'm going to use a couple of nuts to keep it in place for the time being. I'm going to mount the tube bases now as well. There's not really very much to do to finish the transformer housing. I've already soldered the leads from the transformers to the tag strip. Now it's just a question of adding the Zobel network and attaching the required wiring. When all that's done, I'll be able to fit the body of the box, turn the whole thing upside down and get on with the rest of the build. The Zobel networks consist of a 10k resistor in series with a 5 nanofarad capacitor. I'm using two 10 nanofarad capacitors in series because I don't have a 5. I'm also using tags on the tag strip to join the resistors and the capacitors together. Right, now I can attach the flying leads to the tag strips and take the connections into the main chassis. I'm using thicker wire for the secondary as this is low impedance. These particular transformers have two primary windings. I'm connecting those in series using one of the spare tags, and I'm going to bring that connection out so I can mess about with it and experiment at a later date. So I'm going to need 3 wires for each of the primaries. I'm going to use this coloured wire here temporarily. I really ought to be using stuff with a bit better insulation on it, but I don't have any of that. I'll get some on order and replace this at a later date. The wires just need soldering, passing through the grommet to the chassis, and a cable tie to stop them being pulled all the way through. So now we can turn it over, and I've marked the cable with a little blue mark and the chassis with a similar blue mark so I know which cable belongs to which channel. And I can fit the tag strip. It's got spacers and bolts for holding the lid on. And we need another pair of bolts for the other side of the lid. And screw it down. The front of the chassis needs a bit of a makeover. Those holes need to be covered up, and it would be good if the thing looked a bit smarter. So I'm going to make a replacement front panel. A temporary solution is going to be good enough, as it's going to get replaced once the amplifier is upgraded to include more features such as an on-off switch, an indicator lamp, and perhaps even twin VU meters. So that gives me the opportunity to try a little experiment. The original front panel looks like it's just a piece of transparent laminate material printed on the reverse side, then perhaps some kind of mask has been applied, and finally the whole thing has been covered with a protective layer of paint. Even if the original wasn't produced this way, it seems like a reasonable method to make a replacement, so I'm going to give that a go. It only needs to be a simple design for the time being. A basic scale for the volume control will be enough for the experiment. I'll add better graphics and other features for the next version. An old egg carton looks like it's going to be big enough to provide a suitable piece of laminate material. My regular inkjet printer can do the printing, and a tin of gold spray paint from the local 99p shop can provide the protective backing. The design has been printed onto a piece of paper, and I'm going to align the laminate to that design so that I know the ink's going to end up where I want it. Once it's tacked down, the whole thing can be run through the printer again. But before printing, I'm going to rough up the surface and apply a layer of glue so that there's something for the ink to key into. And once the ink is dried, the paint can go on. Well, the results look promising, and with a bit of tweaking I think this method could produce excellent results. Before I get going with the rest of the build, I'm going to sort out the potentiometer. I'm mounting on a piece of matrix board, mainly to give me somewhere to place the DC blocking capacitors C2 and C5. Some Vero pins allow for easy connection of two pairs of screen cables. The first pair of cables carries the input signal from the RCA sockets to the potentiometer, and the other takes the signal onto the tube inputs. And here's the finished item. I've picked out the resistors that are needed to complete the amplifier channels. They're all 1 watt apart from the 10 meg resistor. That's going to be a 1/4 watt resistor because that's all I've got. I've already fitted the 10 meg grid resistor on one of the channels, and that goes between the tube base and the ground tag for that channel. I'm not going to record me soldering the components in. There's just not enough space to get the camera, my hands, the soldering iron and the tools in there at the same time. This is it with most of the components fitted. From left to right, along the bottom are R1, R2 and R5 connected to a ground tag. Next is R3 connected to the HT tag. C1 is connected across the top of the tube socket, and R4 is connected to the right hand side of the tube socket. Finally is R6 connected between the tube socket and a tag with a link back to the tube socket. This is the other channel. It's virtually identical. Also, I've added a heater supply. That's the red and black twisted pair going from pins 4 and 5 on one tube socket to the other tube socket to the tag strip. Now that those components are soldered in place, I can fit the potentiometer board. I've put a spacing nut on the collar to get the collar to sit at the right depth, not to stand too proud of the front panel and interfere with the knob. I'm adding a shake-proof washer to that as well. Now the whole lot can go through the front panel. I can fit a nut to secure the whole lot in place. And tighten it all up. The spindle can be cut to the right length. And the knob attached. The potentiometers can now be connected to the tube inputs. And the speaker terminals wired in. Not forgetting that the leads from the transformers need connecting to their respective valve bases and HT supply. I'm trying a bit of an experiment here, so don't follow this wiring exactly. If you stick to the original circuit diagram, you should be okay. I've started on the power supply section now. I've begun with the HT smoothing network. I'm going to be using the 3 leftmost tags on the tag strip. The center of the 3 tags is going to be the ground. The leftmost tag is going to be the input, and the 3rd tag is going to be the output. I'll daisy chain from the ground tag to the ground tag of the first tube base, and then to the ground tag of the second tube base. And then I'll daisy chain from the supply tag to the HT tag of the first tube base, and then the HT tag of the second tube base. And that's with those connections made. I've also added 2 more pairs of wires, both red and black, one for the HT supply coming in and one for the heater supply coming in, and the red wire for the heater supply is marked with some black flecks, so I can differentiate between the two. The amplifier circuit is pretty much complete now, and it just leaves the power supply section outstanding. The smoothing components for the HT section have already been dealt with, and as the boost converter is a bought-in unit, it could just be bolted to the chassis and wired up. However, I am going to replace its heatsink with a larger externally mounted version. I'll get to that shortly. But at the moment the heater supply is just a collection of components and a piece of blank matrix board, so I'm going to get working on that first. The first thing I've added to the board are the input and output connectors. There's obviously an in and an out, but I also want to be able to daisy chain the power input to the next board, i.e. the boost converter, so I've added an extra connector, and that will be just wired up in parallel with the input. I've also attached the LM317 and made 2 mounting holes, so now I can work out where to drill the holes in the chassis. I was going to etch a circuit board for this, but I don't have any etchant at the moment. But I will use the intended layout as a guide for the component placement. After a while it looks like this. Eventually it looks like this. And of course it's always worth checking the results against a circuit diagram. Now to the boost converter. Once the original heatsink has been removed, the legs on the MOSFET can be extended to reach the new heatsink. There are already 2 posts along the back edge of the chassis that can be used to mount the board, but I'll need to add some support along the front edge of the board too, and of course it's going to require a hole there too. It all just needs bolting together. And last but not least, the wiring. I'm just using screw terminals, so it's really straightforward. Everything is connected up and ready to go. I've taken the precaution of fitting a pair of very used, very old PCL82s that I bought as a job lot specifically for the purpose of these initial tests. The HT is set to 220 volts, various of the voltages have been measured and checked, there's no smoke, and the tubes are glowing gently. So let's have a listen. I think I'd better stop there in case of running into YouTube's copyright problems. But not bad at all, much better than I'd expected, and more than loud enough despite there only being 1 tube per channel. You've seen the build and you've heard its performance a little bit, so what about the costs? Well, here's a breakdown of what I spent. You can pause the video if you really want to examine it in detail. But the total was well under £70, and that includes an estimate of £15 for items that I've taken from my component and hardware drawers. Perhaps I've been a bit lucky finding those tubes and transformers at such a good price, but even if those items were twice as much, the total cost would still be a long way short of £100. And there's still plenty of experimenting and upgrading to do for this amplifier. I may well add an additional video on those topics in the future. But in the meantime, I think I'll also be using it regularly, as I really do enjoy listening to it. A word of caution though, this type of amplifier uses dangerous voltages. If you want to dabble with the kind of technology that it uses, you should acquaint yourself with the correct way to deal with those hazards. I can't guarantee that even if you follow exactly what I've done, you will get exactly the same results, as a significant factor in the amplifier's performance is down to the transformers. Perhaps you might get a better performance, or maybe not, but you won't know until you try. Anyway, bye bye everybody, and thank you for watching.